In section 1, we talked about our measures of center. So in lesson 2, we're going to start talking about our measures of variability. So our first measure of variability is our range, which tells us the difference, meaning subtract, between the high and low values. It also helps us describe if the data is spread out. Or posted together. Okay, so your range is the difference between your high and your low values. All we're doing is subtracting our max minus our min. And then once we have our range, it's going to help us describe if the data is spread out or close together. Obviously, a large range would tell us that the data is very spread out. Small range would tell us that it's pretty close together. So a couple quick examples. We want to find the range of each set of data. So we have a number line here with some study times plotted for us. So our maximum, our high number here, would be 38 minutes. And then our minimum, so down to the other end, would be 10 minutes. There are 2 at 10. That just means that 2 different people studied for 10 minutes. That doesn't matter. Minimum is still 10. So to find our range, we're going to take our max minus our min, which gives us 28 minutes. All right, another quick example. The age and years of Mrs. Tisnick's grandchildren are 27, 8, 5, 19, 21, 10, 4, and 21. So we get our maximum. If we go through here, they're not in order, so you can put them in order if you need to, or we can just pick out that 27 years is our maximum. Our minimum, if we carefully go through again, I see an 8, I see a 5, and then I see a 4, which is smaller. So our minimum is 4 years. So 27 minus 4 gives us a range of 23 years. Both of these were relatively close together. Okay, so now we've done range. We did that quickly because I believe you guys have done range in the past. We want to talk about our quartiles and our interquartile range. So in a set of data, the quartiles are the values that divide the data into 4 equal parts, meaning each part has 25% of the data. I recall that the median of a set of data separates the set in half. So half of 50% is below the median, 50% is above the median. And then our interquartile ranges, or our Q1 and our Q3, as you can see down here, separate them into our 25%. So the median of the lower half of a set of a data is the first quartile, or Q1. The median of the upper half of a set of data is the third quartile, or Q3. So you're basically just finding your median 3 different times. One median to cut it in half, and then another median to find your Q1, another median to find your Q3. So in words, the interquartile range is the range of the middle half of a set of data. So it's the difference between the third quartile and the first quartile. So range, you're still subtracting, but now instead of your absolute max and your absolute min, you're taking your Q3 minus your Q1. Okay, so lots of words there. If you look at the bottom of the page, we're going to kind of flip back and forth here. Or I'm going to flip back and forth. It's all on one page for you guys. We're going to use some of these ideas. So we want to find the measures of variability for the data in the table. We know we're working with our median, which means we want to put our numbers in order first. Now, as you do this, don't be afraid to cross numbers off as you use them. That way you don't skip any. So 25, 38, 39, going through, I see a 40. Next up is 44. then 45, 49, and last up 53. I see there's 8 numbers. I got 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so our range, max minus min, so 53 minus 25, now that they're in order, gives us 28 feet. Our median, I know I have 8 numbers, so we have to go in between these two. So that's going to be the average of 40 plus 44, which gives us 42 feet. Now, Q1, this is kind of what's new here. I did not use the 40, so we're going to include that in this set of data. I want to find the median of 25, 38, 39, 40. Again, I have an even amount, so it's in between these two. So the average of 38 plus 39 divided by 2 gives us 38.5 feet. And then our Q3, again, even amount. So in between our 45 and 49. Gives us a Q3 of 47 feet. And then kind of squeezing over here, your interquartile range, 47 minus 38.5, which gives us an IQR of 8.5 feet. So again, this is our median. Here's our Q1, and here's our Q3. Now we will do some practice with some even amount of data and some odd amount of data so you guys can see the difference between finding your medians, your Q1, your Q3, when you have even numbers and odd numbers, because they do work slightly differently. But there's one fully worked out example for you. Hopefully that at least gets you started working with your quartiles. All right, the last idea for this section is talking about outliers. So outliers is the data value that is much larger or much smaller than the median. So we're looking for numbers that kind of don't belong. If we look at our animal speeds, we got a 12, 15, 25, 30, 32, 35, and 70. For this set, they're already in order. I have 7 numbers. So my median is 30. 70 here, much larger than 30. And honestly, you probably didn't even have to find your median. You could have just looked. From 12 to 35, they're all pretty well grouped together. Then all of a sudden, from 35 to 70, our cheetah is doubling the speed of the next fastest animal. So 70 is definitely an outlier. Then our movie running times, we have 105, 120, 155, 115, 96, 100, 110, and 120. If we put these numbers in order real quick, we would find that our median between 110 and 115. So the median would be 112.5. Now if we check out the rest of our times, our minimum here of 96 is only 16 away from our median. Everything else is pretty well close together until we get to that 155. That's adding an entire half hour to the next closest movie time. So that 155 would be an outlier. It's not majorly outside of the time, but it is an outlier. All right, one last example. Comparing data sets. So the number of magazines sold by each student in 2 homerooms is shown below. Thankfully, they are already in order for you. For part A, we want to compare homeroom 104's range with homeroom 102's range. So part A, homeroom 102. Our range from 2 to 40, we just want to subtract those. So the range is 38. And then homeroom 104. We go from 1 all the way up to 51. That gives us a range of 50. So now if we want to talk about comparing them, 38, your data is closer together. And then our 50 is clearly more spread out. Okay, we look at part B. Does either homeroom have an outlier in the data set? Well, if we look through, all of our numbers here are increasing by smaller numbers, 14 to 16. At most, we're jumping up 7 right here, but overall, they're pretty close together. And then if we look at homeroom 104, again, they seem pretty close together, some repetition, until we get from 26 to 51. That's quite a jump comparing it to the rest of them. So yes, homeroom 104 has an outlier of 51. And then last up, part C. How does the outlier affect the range for the number of magazines sold in that homeroom? Well, without the outlier, so if we took that 51 out, the range is only 25. So it actually doubles our range, so that tells us that it is definitely an outlier. Falls way outside the rest of our data. Right, that is the end of section 2.